We're back at our Powderview project here, and I thought we'd go around and have a look at some of the work that we were originally intended to do and some of the scary stuff that was hiding behind some of the demolition and some things that you might want to consider for your house because some of this stuff is really not all that obvious. So under the new requirements for stratas in British Columbia, stratas are required to engage with envelope engineering companies to do maintenance schedules, identify what the future repairs might be to make sure that stratas have enough money to facilitate repairs when they come. So what we're seeing here is some regular maintenance. This building is about 30 years old. I'm standing on the concrete structure that is the underground parking for this wood-framed multifamily building. And what you can see is that the concrete for the underground parking is slightly bigger than the wood frame building itself. And what we're doing here today is we're looking at replacing the waterproof membrane here that not only keeps the car park dry, but also is here and intended to prevent water from going in to the crawl space underneath. And so over the last number of years, this membrane has failed in a number of places, and it has resulted in a lot of water collecting in the crawl space. And that water in the crawl space then has the consequences of potentially impacting the indoor air quality and the structural framing integrity of the wood frame building. So one of the things to note is that the time the building was done, it was only required that this waterproof membrane come up about 8 inches. Whistler gets a lot of snow. Sometimes we see a lot of snow building up against buildings. So this new membrane is going to be best practice, and it's going to come up considerably higher to make sure that there is no risk of any further water ingress getting in here. So as we go through, membrane gets replaced, comes further up the wall, siding get replaced. We can make sure that the crawl space stays dry and that the underground parking stays dry. Going on here is the old membrane was protected with a concrete topping. Guys are having to pull this concrete topping up so that we can get to the membrane and make a replacement. What we're going to do is we're going to replace the concrete topping with hydropress pavers so that if there is a problem in the future, it's a simple matter of lifting up the 2x2 pavers, facilitating the repair and putting them back down. Nobody will ever have to go and jackhammer up all this messy concrete again. We are down in the underground parking of the buildings here, and as you can see from the ceiling, there's been some extensive crack repair, and that was done as a consequence of water that has been getting into the crawl space above the concrete podium and leaking down into the car park. So what we're going to be doing is we're actually going to be addressing the waterproofing issues on the podium itself so that that crawl space stays warm and dry and will effectively eliminate any of the water that's been dripping down into the crawl space. So what we can see here is this is a crack repair that was done that is not actually working because it's virtually impossible to fix a leak from the inside. The only way to effectively leak repair is you've got to solve the leak at its origin. And we're in the middle of this underground parkade. And so this is indicative of actually how much water is sitting in the crawl space above us. And that water has all ingressed from failure of that membrane around the perimeter of the building. So one of the scary things that we uncovered here, of course, is what you can see is this lower framing is really, really rotten and has badly failed. These stairwell structures were added after the original building was built. And although they made some effort to make sure that this was waterproof properly, as you can see, it did not work. And what is particularly interesting about this is when we arrived at the site, this was not visible in any way. The interior finishes looked fine, the exterior siding, everything looked perfectly good. And it wasn't until we started to remove the lower floor sheeting to address our waterproofing requirements that we started to uncover this. And all 4 stairwells in this building are suffering from the same thing. So some very, very extensive failure here. What we're going to do is we'll cut the rotten sections out, replace it with new material, redo the interior finishes, and then of course proper waterproofing to make sure that this doesn't happen in the future. So here we got 2 more stairwell entrances. You can see that they have suffered some very similar rot damage as the other one. This one over here is the same. And then we can get in here. You can see that this is the original podium framing, crawl space framing. And while some of that black is from the torch on, most of the black that you see on this treated plywood is as a consequence of just being significantly wetted over a long period of time. You can also see standing water here, so we're going to make sure that this is sloped properly. Water drains to the drains in the way it was originally intended. So this is a great example of how an integrated approach can work for a strata in terms of identifying whether it's repairs or maintenance or significant rework. We were initially engaged by the strata to come in and have a look at what the problem might be. We were then instrumental in bringing RDH envelope engineers into the project. We worked with them to create that original scope of work that was then used as the tender document. We, amongst others, responded to that tender document and were lucky enough to be the winning proponent. I just want to do a really big shout out to the RDC team, and the guys were able to activate really quickly. As you can see, here we are at work, getting her done.